Okay, problem number 22. We got energy costs vary greatly with energy source. Coal is $25 per ton, gasoline at a pump price of $2 per gallon, electricity at 10 cents per kilowatt hour. Conventional practice is to put these on a common basis by expressing them in dollars per gigajoule, which is approximately 10 to the 6 BTUs. For this purpose, assume gross heating values of 29 megajoules per kilogram for coal and 37 gigajoules per cubic meter for gasoline. Part A. Rank order the three energy sources with respect to energy cost in dollars per gigajoule. B. Explain the large disparity in the numerical results of Part A. Discuss the advantages and disadvantages of the three energy sources. Okay, let's go. So let's go ahead and calculate energy cost of coal. So we can maybe do some conversions. We're given 25 USD per ton. And I'm not sure how they're... Is it metric ton? I don't know. I'm going to go worst case. Well, these are all just kind of weird. Let's just go with metric ton. Assumption. Ton means metric ton, which is 1,000 kilograms. All right, so we need to do 1 ton of coal. So we're going to go with, for every ton, you have 1,000 kilograms of coal. And for every kilogram of coal, you get 29 megajoules of, let's see, let's go in joules. 29 million joules. Then we'll put in the factor here. For every 10 to the 9 joules, you get a gigajoule. So that should come up to be units of US dollars per gigajoule. Yeah. Okay, that's 25 times 10 to the 9, 1,029. All right, and units of USD per gigajoule. Should plug that into the calculator. You get 0.86. 8621 USD per gigajoule. And this is, of course, coal. Okay. Calculate energy cost of gasoline. $2 per gallon. Okay. All right. And then we got energy density. Let's see. You need to get this into whatever energy density it has for gasoline. 37 gigajoules per cubic meter. So we need cubic meters. Okay, we got it in cubic meters now. Now we need to apply that 37 gigajoules per cubic meter. Okay. So that should give us an answer in USD per we need to invert that, don't we? Yeah, that's better. USD per gigajoule. Okay, this comes out to be 2 times 264, about 172 divided by 37. 14.27, 956,757. That, which will reduce down to 3 sig figs. 14.3, that. Add in gasoline. Okay. Okay, then calculate energy cost of electricity. $0.10 per kilowatt hour, down to 4 decimal places. Let's go from kilowatts to kilojoules first. Every kilowatt, we got 1,000. 1,000 watts. For every watt, we got 1 joule per second. And for every, we got joules, don't we? Yeah, joules is in the right spot, should be in the denominator. And time. Let's get rid of hours, put it into seconds. For every hour, we got 3,600 seconds. All right, then we'll go ahead and reorder this. Namely this one. Joules, and then put seconds up top. Then group everything up. 0.1000 times nothing. 1,000 times 3,600. Yep. Then units, we're left with this. Kilowatt per watt. We're left with watt second per joule, hour per second. That reduces down to USD per, well, see, we're not done yet. We gotta get to gigajoules. Might be a little too early. Yeah. So we're in joules now. Now we gotta go from 10 to the 9 joules per gigajoule. To the 9. Okay, so if I'm right about that, we should just be left with USD per gigajoule. Let's see, kilowatt, kilowatt, hour, hour, watt, watt, second, second, joule, joule. Yep, everything simplifies, and then we do this, it's 0.100 times 10 to the 9 divided by 1000 divided by, again, 3600, 27.77 7 USD per gigajoule. Let's go with 4 decimal places. Now, does that make sense? Okay, so electricity is much more costly than gasoline, per raw gigajoule. Coal is much cheaper, but you have to process it. You can't just plug your coal into your toaster. That'd be kind of nice. So, problem 22, part A, answer. Coal, gasoline, and electricity, as described, can be ranked in terms of USD per gigajoule, like so. And then we'll put a little, we got descending order of that. So we got, is it energy cost that we're talking about? Yeah, I guess so. Energy cost. So most order, the most expensive is electricity, looks like. Next is gasoline, then coal. Part B, explain the discrepancy. Problem 22, part C, B, answer. While it is the cheapest, although coal has the lowest energy cost, the amount of processing required in order to convert its stored chemical energy into useful work although coal has the lowest energy cost, there is this cost does not take into account the amount of energy lost due to inefficiencies in processing coal's stored chemical and processing steps that convert the energy in stored chemical bonds of coal into useful work. For example, in order to make let's see, in order to run a 100 1,000 watt computer, the chemical energy stored in coal must be converted into a temperature difference converted into heat that is consumed by a heat engine, consumed by a steam engine, which then converts rotating mechanical energy into moving electric fields, which are converted into electrical current, which then must be transmitted over a transmission line that itself has to the computer's location, possibly with several likely with a voltage step up and step down transformer, likely with several electrical transformers raising and lowering the voltage. And as the energy is transferred. And result is that each step of energy conversion is not 100%. How do you write percentage? Percent efficient. This is likely why the cost of electricity, the energy cost of electricity is so much higher than that of raw coal. As for gasoline, a computer that runs on raw coal would cost of gasoline is the energy cost of gasoline is, as for gasoline, it also is a fossil fuel, but it is a it also must be processed before being burned, being consumed by a combustion engine, processed by a petrochemical refinery before being consumed by a combustion engine. Also the equipment required to perform the energy conversions. Also the processing equipment required to perform the energy conversions cost money, and raising the energy cost beyond that which is required to produce raw coal. Overall processing equipment and cost of extraction. Well, electricity is electricity, although more expensive than gasoline or coal. In this example, is also a much more convenient form of energy. Is also much more readily consumed by end devices such as computers and refrigerators. Okay, I think I'm happy with that. That's problem number 22. I don't know why they give me gigajoule in terms of BTUs. Weird. Okay, well that's problem number 22. Uploading to the repository.